The topic we chose to do our project on is capacitors by David Szymanowski and Haimi. We are going to talk about the history of capacitors, how it works, why they are used, and fun facts. Who invented the capacitor? The original inventor isn't clear. There are records that indicate a German scientist named Ewart Kleist invented the capacitor in November 1745. A few months later, a Dutch professor named Peter van Rosenbroek invented the Leyden jar, which is credited as the first capacitor. Kleist didn't have detailed notes, which is why a lot of people didn't credit him for his invention. As time passed on, both of them have been given equal credit. The Leyden jar was invented by Peter Rosenbroek, and it is a glass jar that is half filled with water. The inside is lined with metal foil, and the glass acts as a dielectric. A metal wire is usually going through the cork on the top of the jar. Charge is connected to the metal wire, and in those times, they most likely used a hand-cranked static generator as their producer for charge. After they cranked the static generator, the jar would hold two opposite but equal charges in equilibrium until each wire is connected. When contact was broken, a charge would be presented by feeling a shock on one's hand or a visual spark. A present-day capacitor is made of two metallic plates. A dielectric material is in between the plates. The capacitor is connected to a battery, and an electric field is created when applying voltage to the capacitor. The plate on the capacitor that is attached to the negative terminal of the battery takes the electrons that the battery is producing. The plate on the capacitor that is connected to the positive terminal of the battery loses electrons. The whole purpose of a capacitor is for it to hold charge. It does this by storing energy in an electric field. It stores the electric energy in a circuit and gives the energy back to the circuit whenever it is needed. It blocks the flow of DC and allows AC to flow. When you disconnect the fully charged capacitor from a circuit, it acts as a temporary battery. They are used in car audio systems, for example. Depending on the size of the capacitor, some of them are able to turn on a flashlight for a certain period of time, while others can power large amplifiers to be used whenever needed. This is a SEM image of a MIM capacitor, and it is a cross-section. The top metal layer is shifted to the right, and the bottom part of the picture is an enlargement of the part of the capacitor, showing how the outer is connected to the metal 3 instead of the top of the capacitor metal. This causes a short in the capacitor.
Over here we're able to see how capacitors are made from all kind of the method. Right here we have a parallel plate capacitor, which are more conducting materials, and beside being conductors in capacitor plates, they have a mechanical strength which can have a resistance to deterioration from electronic chemicals. On the other side we have a superconductor capacitors. Superconductor capacitors store a lot amount of energy. Even when they store a lot of amount of energy, superconductor capacitors cannot have excess amount of voltage. Over here we will see how capacitors were working in the recent and how it would be in the future. Capacitors in the recent were only able to permit electrical energy to be stored in a long charging time for a least period of time or for a short periods, and that would be under controlled conditions. Here we will see some real-life example of capacitors. One of them is capacitors as sensors. We can use this kind of capacitors for an alternating voltage which causes the charges to continually reverse their positions. The moving of charges creates an alternating electric current which is detected by the sensor. The other one we have is condenser aerodynamic microphone. Condenser and dynamic microphone can actually use a capacitor to convert acoustical energy to electrical energy. The other one we have here is CMOS sensor and a water pump capacitor. CMOS sensor is an electronic chip that converts photons to electrons for a digital processing. And why are capacitors important? Capacitors are useful for storing energy, tuning circuits, thinning capacitor, and smoothing voltage.